In this video, we're going to talk about the property of density. Density is a ratio of a substance's mass to its volume. So we can measure the density of all different kinds of substances, liquids, solids, gas, it doesn't matter the state of the matter. So you'll see here on the screen the formula for density. D is equal to M over V, and you can use the density triangle. I think that's super helpful, where it's D, M, V, like the Department of Motor Vehicles where you go get your driver's license. D, M on top, and then V. The reason this is helpful because it can help you figure out how to solve for other variables. Maybe you're given density and volume and asked to solve for mass, and you just simply cover up whichever variable you're solving for. So let's say we are solving for mass. Take your finger and cover up the M, then you'll have the formula for mass. It's going to be D times V because they're right next to each other. Let's say that I am given density and mass, but I need to find volume. Okay, cover up the V with your finger. Well, now you have M over D, and that's exactly how you would find the volume, is mass divided by density. So super helpful there. Put that in your notes while you're studying density. You will have some density problems on your test. So density is an intensive property, meaning it doesn't depend on how much stuff you have. For example, a cup of pure water is going to have the same density as a pool of pure water. It doesn't matter. The density of water, for example, the accepted value is 1 gram per milliliter, which is the same as 1 gram per cubic centimeter. Those are the two density units that you're going to see. Oftentimes, grams per milliliter, you're going to see that associated with the density of liquid substances. And then grams per cubic centimeter is typically the unit used to measure solid substances' densities. I really like these pictures here. I think they do a really good job of showing density. For example, the picture in the lower left-hand corner, this is something that I did, I remember doing in 7th grade for a science lab, but it's a density column. You can take different liquids and actually stack them on top of one another because they have different densities. So for example, you see down at the very bottom honey, and you probably know from experience, honey is very thick. We say it's very viscous, but it's very dense. There's a lot of mass packed into that volume. And then you see the substances get less dense as you go up the density column. So the more dense something is, the closer to the bottom it is. The less dense it is, the closer to the top it's going to be. Did you know that Diet Coke is much less dense than regular Coke? Do you know why? You can probably think about the difference between Coke and Diet Coke and come to the correct assumption. Coke has a lot more sugar in it as a sweetener, whereas Diet Coke contains an artificial sweetener. It contains much less, and that artificial sweetener has a much lower mass. So therefore, even though the volume of the cans are the same, the masses are different. The mass of regular Coke is much larger than the mass of the Diet Coke, which is why you can see in this picture the Diet Coke is actually able to float in the water here in the aquarium versus the regular Coke, which just sinks straight to the bottom. Sometimes you'll have an object that's irregularly shaped. It doesn't have a definite length, width, and height to measure volume. So we can use something called volume by displacement, meaning I can take a known substance like water, like I have here in my graduated cylinder, and I can take something such as these metal pieces. I've got some thumbtacks. I can take a known amount of these pieces of metal, measure their mass first, and then as I put them in the graduated cylinder, if I can get them in there, oops, I can take my initial volume without the metal pieces in there, and I can subtract that from my final volume and see how much water that the metal pieces actually move the water. Take a look here on the screen at the example. I start with a graduated cylinder at 150 milliliters. Okay, I'm reading from the bottom of that meniscus. I start at 150 milliliters, I place the rock in, and I notice that, let's see, it goes up to about 170 milliliters, actually right at. So I can see that the rock moved the water up 20 milliliters because I took 170 minus 150. Therefore, I can conclude that the volume of this irregularly shaped object is 20 milliliters or 20 cubic centimeters. And this concludes our density video.